What's going on, friends? Today we're going to do one of the very recent rooms released in TryHackMe. The name of the room is Linux Process Analysis. And this room is a free room. It means you can attempt or you can deploy the machines on this room. Alright, so what are we going to talk about in this room? So basically, as the title suggests, it's about Linux Process Analysis. And once we deploy the machine, that's the terminal of the target machine, which we're going to investigate. So basically, you will put yourself in the shoes of an investigator, incident responder, or an analyst, and you will try to uncover indicators of compromise related to this machine. How? By analyzing the processes, the services, and the autostart scripts on this machine. So this video is very important if you want to learn how to perform forensic or live forensic analysis on a Linux machine or an infected Linux machine. Before we start anything, in live forensic, we always use what is called as the clean analysis tools. So basically, for this machine, you can go to cd/mnc ls cd usb. As you can see here, we have the tools that are needed to perform the analysis. It's very important to note that when you perform live forensic analysis on a compromised or infected machine, don't use the tools in the machine that are pre-built with the machine, the binaries, because it's highly likely that they are modified or their integrity is violated. That's why we use clean tools. So what we do, we use a USB, we mount the USB on the target machine, and now we can access the tools. Instead of accessing the tools by just using their path every time you want to invoke them, what you can do, you can add them to the environment variables. So basically you can say export path, and here the first path is /mnt/usb/bin, okay, and mnt usb sbin. So here we are adding these two directories, bin and sbin, because they contain the necessary tools to perform the analysis. And the next command, it's about the ld library path. Gonna paste this here, and we're good to go. Now we can use the tools in these two directories without the need to specify the full path. So what's the first thing we want to do? We want first to analyze the processes. That's why we're going to use ps. ps lists the current running processes along with the PID of the process, the terminal. As you can see, TTY is the terminal associated with the process. And here it's the time, the cumulative time consumed by the CPU. And lastly, we have the CMD, the command associated with the process. So the process with 2199 PID is executing bash, and this is the process for the PS utility. Moreover, if you want to see the processes associated with a certain user, all you have to do is to mention the user with -u switch. First, we're going to learn what are the users on the system. So cat etc password, and we can see the users that have shell on the system are this one, backdoor. We have Eduardo and Janice and Franklin, investigator. So in order to see what are the processes run by one of these users, let's try with different user. This time we can try with this user, and now we can narrow down the output to only the processes that are running by this user, Janice. Okay. Now what's the next thing we can do? The next thing is to investigate what is wrong with the current processes. We want to find out the process that stands out from the other processes, meaning whether it is malicious or P9. So to do that, we're going to use ps-efh. So here we use -e to list the full running processes, and -f full format, and -e for hierarchical Fourier, or to see the relationships. Now I have a long list of processes. Of course, as an analyst, you're gonna try to skim through these processes and find out what is weird here. So basically, one way to do that is by looking to or by looking through the CMD, the command the process is trying to execute. Once we see something that is not familiar, we can investigate further. Check this out. So this line looks like here there is a listener on this port, a process that listens on this port run by Janice. This is the PID of the process, and looks like there are other associated processes with this process, meaning we have this and we have this pipeline temp/f. These three processes are not familiar comparing to the other processes. So what we're gonna do here, we're gonna try to dig deeper. First, let's see what is under this directory. So cat temp f. So this looks like, let's see here. Okay, it's not responding. ls-la temp. So this is the file f, and as you can see, it's pipeline. This pipeline is associated with the listener running here. And basically this is a bind shell. And this bind shell is the first surefire sign that this machine is compromised, and it is used, and this bind shell is used for persistence, meaning the attacker can connect to this machine on this port whenever they want, and they will be able to spawn a shell here. Now that's the first indicator here of compromise. Now, in order to investigate further, one way is to grab the PID of the process. In our case, it is, let me check the columns. So this is the PID. It is 1732. Let's check the opened files by this process. One way to do that is to use sudo lsof-p, and we're going to need to grab the password from here. See, these are the files opened by this process. We can check here the username, we can check the PID, and we can check the size of the file and where it is located. So we can see /temp/f, and we have, as you can see here, guys, confirmation that this is a pipe. If you want to investigate the other processes, all you have to do is to grab their PID here. So this one has the PID of 1731. So here 1731, we see the opened files, and we see here pipes as well. Now, once we see a malicious process and we check the opened files by this process, it's worth investigating the child-parent relationships between the processes. We want to find out if there are other processes spawned by these malicious processes. So to do that, we're going to use PS3. PS3 lists the processes in a child or parent-child relationship. Now, most probably this output is overwhelming, so we're going to narrow the focus on the process in question. To do that, we're going to use PS3-P, okay, and -S, and then we're going to provide the PID. Look here. So that's the main process, netcut, right? This is the child process. Now, we have another process with PID of 1726. This process is the parent of the netcut process. So now we have another clue here about another process, and we want to investigate further the nature of this process. So to do that, we're gonna use lsof, okay, or sudo lsof, and then we're gonna use -p 1726. See the opened files by this process. So this process has these files opened. Bash, and we can see that there is a script here located under the home directory of user Janice. So we can just cat home to take a look at the script. Okay, check if log file exists. Create log file, main command rm-f. It removes the pipe, and it is a reverse shell. This is a netcut reverse shell. So that's the parent process of the bind shell we saw earlier. Okay, so what we're gonna do next, we want to check if these processes are running in real time. So we can use the command top followed by, since we know that the user running these malicious processes is Junice, we can just narrow down the focus to that user. And we can use -df to check the processes running, or to update, sorry, the output every 5 seconds. And we want to display the full path of every process, -c. And lastly, -u, we specify the user. So indeed, these processes are active now. So meaning there is a bind shell running on this machine waiting for the attacker to connect to it. Now let's see the questions related to this task. So the first question here, or the first task, task 3 processes. You can scroll all the way down and see we have 2 questions. Which command lists all open files and the processes that open them? LSOF. Use PS3 to list out the process hierarchies. What's the name of the NC process parent? We already answered this question. Okay, now the next task, it is about Cronjobs. So now after we investigated the processes and we identified the malicious processes, now it's time to find out if these processes are part of Cronjobs. Now usually Cronjobs are 2 types, system-wide and user-created. Usually system-wide Cronjobs are created under ls, la, etc, or let's say cat, etc, cron tab. These are system-wide cron jobs, meaning they run as root. So once we see an entry here, it is worth investigating because this entry runs as root and it runs the script located at this path. Let's investigate further what are the files under this path. So cd or ls var vr temp backup. Okay, it looks like it's already a script. So vr temp, and it is a bash script, but it does what? So here it creates an archive. Looks like it's a backup for the web files, and it executes another command which is cur and performs a call to this suspiciously looking domain. So this is another sign that the machine is compromised, and there's a cron job that connects to what seems to be a C2 server. Now once it connects to the C2 server, it retrieves a bash script called install xmrig, and it executes the bash script. So these are C2 codes or C2 queries to a C2 server. Now these are system-wide cron jobs, but on the other hand, sometimes user creates cron jobs. These cron jobs are located under ls var spool cron tabs. Permission denied. Let's try with sudo. So as you can see, guys, we have cron jobs for every user registered on the system. You can specify the username, let's say Bob, and see under Bob, or we can use cat and take a look at the cron jobs created by this user. Permission denied again. We're going to use sudo one more time. And these are the cron jobs that are running under Bob. So we can see we have 2 scripts part of this cron job. And basically you can see they run these scripts. The first one runs every 10th minute, and 5 it means that the hour, so it runs 5:10. Okay, and then we have every day of the month, the first wildcard for every day of the month. The other wildcard, it's for the month, so wildcard it means every month. And lastly we have day of the week. Wildcard it means every day of the week. So it means that this script runs every day exactly at 5:10, and this one it runs at 4:30 every single day. Okay, so now we checked the system-wide cron jobs, and we checked the user created cron jobs. We can also check another directory. It is under cd or cat etc cron d. Okay, here you can check the cron jobs running daily, hourly, and weekly. For example, daily, you can see these cron jobs. Now we can check weekly, the weekly cron jobs, so on and so forth. Now, one last thing. In order to check the cron jobs that are running by a specific user without the need to check the path that we checked earlier, here we can just use sudo cron tab -l -u, and we specify there's a, let's say it's a Janice, and we can check the cron jobs running here. We can see that under this user we have the same script we checked earlier. This one, if we review again the content of the script, home, and it is a reverse shell. So we have a mix of reverse shells and C2 scripts that run as cron jobs. Alternatively, you can check out the one-liner here. This one-liner, what it does, it loops through all the users and lists their cron jobs. Let's try it. See, it checked the cron hourly, and then it checked the other entries, and we found that found the cron tabs for every single user. Instead of checking them individually, you can run this one-liner. And lastly, we can check the cron execution logs. Sometimes a cron job is created and then deleted for some reason. If you want to find out what are these cron jobs that were created, or for some reason they were deleted or resulted in an error, you want to check the cron execution logs. Cron execution logs can be found under sudo or under var ls var log, and here we can see the syslog. They can be found here. So what you're going to do, you're going to do sudo grep cron var log syslog, right? And then you want to rule out specific cron jobs. These cron jobs could be associated with error or failure in executing this said job. So you can just grep -e failed error fatal. See, there is nothing. So all cron jobs were executed successfully. Or you can just use grep -i and see cron jobs related to specific user. Of course, I'm talking about the logs of these cron jobs. So look at this one. We have one. And at the very end, we're going to now check the questions in this task. Search around the system for suspicious system-level cron job entries. What is the full URL of the C2 server? All right. So remember earlier, we checked our cat etc cron tab, which contains the cron jobs or the system-wide cron jobs. Now, if you attempt to list or to create, to display the contents of this script, see, you might think that this is the C2 domain. While it is one of the C2 servers used to serve this script, but apparently, based on the answer here, there is another one. How to find it out? We're gonna go over these entries. So cat etc cron I do it all the time like this. ls. So here there's nothing that stands out. We can again check daily. Apparently, if you check these, nothing stands out. Weekly. Now to monthly. Okay, so nothing here. And lastly, we're going to check so we checked daily, weekly, monthly. Let's check the hourly one. So in the hourly, there is one. So to find what is this cron is running, we're going to do We're gonna execute this command, and that's the other C2 server. This is the answer. List the user level cron jobs in the system. What is the hidden flag in one of the scripts? We actually talked about this. That's why I'm gonna use the given one-liner here, because it's quick and gives me all the cron jobs of all the users. Let's go back to the question. What is the hidden flag in one of the scripts? See here, we have 3 scripts, or more than 3 scripts. There are 4 scripts. Each one of these scripts is running as a cron job. But these scripts are created by different users, Janice, Bob, and Elia. So basically here, the one we're looking after is this one, because the name is self-explanatory that it contains the flag. So what we're gonna do, we're gonna copy this and display its contents, and we have the flag. Use PSPY64 to monitor executions occurring through the system. What is the decoded flag that is echoed every 15 seconds? Remember that PSPY64 is one of the tools that are not only used in forensics, but also in Linux privilege escalation. So this tool is very useful if you want to list the running processes in real time. What are the commands they are executing, along with the PID and the file path, and so on and so forth. So we're going to use this one to answer this question, PSPY64. So here in the question, it is stating that there is a flag, or the flag, encoded flag, that is echoed every 15 seconds. We're going to need to find this. Okay, now some output. Let's go over the output. We want to look for a pattern of encoded string. It is echoed every 15 seconds. So now look at this one. Sudo user add -m-p. So it's creating a user. That's the backdoor user. And then we have this one, kill. It is killing one of the processes, and we have the decoded value. So now you're going to take this and execute echo base 64-d, and now we have the decoded value, which happens to be the flag. Right, so now we talked about investigating the processes, the cron jobs. The other avenue to go over is the services. Okay, so now we know that the machine is infected with a bind shell, let me say, and the bind shell is running as a cron job along with other scripts that are also running as a cron jobs, and these scripts perform or are performing C2 calls to retrieve further malwares to the system. The other avenue now to go over is the services. Usually the services are managed by systemctl. So to list all the running, we're going to start with listing all the running services. So sudo systemctl, okay, dash list, or without dash list, units dash type equal service dash state equal running. Let's take a look at the running processes. We want to spot any unusual process. So we have here the unit name, the service name, the status, whether it is loaded, the description, and let's see here. So we want to look for unfamiliar process, unusual one. Look at this one. It's the service that bears the same name of the malicious process we witnessed earlier. And the description is flat out saying that it is a backdoor service. And it has a flag. Probably this flag answers one of the questions. Let's check it out. List all running services on the system. What is the flag you discover in the backdoor service description? Okay, we already answered the question. Now, we now know that the malware created a service as well. Okay, so in order to find more details about the service, such as the executable or the script behind this service, we're going to use the same tool, systemctl. So sudo systemctl status. We want to report on the status of the service. The service name. Okay, now the status report is that the service is active. Okay, but there is more important information to take a look at. So here we can see what seems to be the script that runs this process, and it runs every 16 seconds, every 1 minute. So this is the process behind the service or the script. We can take a look at this one. User, or let's copy it. And now, before we jump to the content here, look, there is a flag here. This flag probably answers the second question. View the journal.ctl logs associated with the backdoor servers. What's the flag you discover? It is this one. All right. So now let's take a look at the script. So that script is creating a user. Okay, the username is this, and adding the user to the sudo words group so that the attacker can execute privileged commands. And this is the flag. Okay, another way to extract more details about specific servers is to use a journal.ctl. So sudo journal. Usually we use journal.ctl to inspect the logs of a specific service. We want to find out, usually to troubleshoot services, we use journal.ctl to take a look at the logs. -f-u, and then we use the service name. Okay, now we see the logs, including the commands the service is executing along with the flag for this task. Okay, now we answer this one. Next, we're going to check the autostart scripts. Autostart scripts are the scripts that run when the machine boots up or when the user logs in. Usually, let's quit. Clear. Okay. Usually there are two types of autostart scripts, similar to Cronjobs, system-wide and user-specific. In this scenario, we're going to focus on the user-specific ones. Usually they are stored under the home directory of the said user. For example, cd home. Let's go to backdoor. And here we list. Usually there is a file named .conf. Conf autostart, but it doesn't exist here. Probably we're going to try with another user. cd Janice. Let's take a look here. And oh yeah, so as you can see, there is this directory .conf. Now we cd to this directory, and there is the autostart. That's the location where you are, or where you're going to investigate the autostart scripts for that are created by the users, not by the system. Okay. All right. So cd autostart, and usually they are they have this extension .desktop. In order to take a look at the autostart script, we can cat key grabber desktop, and we can see here. So first thing first, it is the desktop entry. This is the standard file header, and the type, it's application. The name of the entry, the name is standard desktop configuration, and lastly we have the command that is executed when this autostart script runs. So it executes cur and performs a call. Okay, so look at here, look at this. Yeah, so here it is, sending the private key of the user Janice to this C2 server. Probably the attacker wants to extract the private keys whenever this user logs in. And by the way, this is another C2 server we've just uncovered. Okay, probably this answers the question here. Scrolling down, we see what is the full URL that receives Janice's private SSH key. This is the full URL. And lastly, identify and investigate the remaining .desktop files on the system. what is the command that executes with the show network interfaces. So now investigated the autostart scripts created by Janice. We're gonna need to go back and see for other users. So we have eduardo.conf. It was like auto, right? Yeah. We have one cat dev. This one is executing another bash script. We're looking to find out the one that executes show network interfaces. We're gonna go back and check out Bob. It doesn't have config. All right. What about Franklin? Okay. Cat network. Looks like this is the one that contains our answer. So the answer is if config. The name is show network interfaces on startup. And lastly, we're going to look at investigating the applications installed on the system. Okay. To view the applications, one way is to take a look at the package manager. So sudo dpackage-l. Here it lists all of the applications installed, of course, using the package manager, not all the applications. That's why in order to fully grab all the apps installed in the system, it needs manual analysis. Okay, I need to take a look at the listings one by one, of course, outside of this one. This only lists the applications installed by the package manager. Another avenue to investigate while investigating apps is to investigate the Vim, or the popular text editor. Usually we actually intend to look at what is called as the vim info. .vim info. Now this file is very important to check out if you are investigating a Linux or a compromised Linux machine, because it contains important information about user interactions with VIM sessions. You can create sessions, entire sessions, using the VIM text editor. Therefore, all the commands that you execute through these sessions are a history of these commands is created and stored at vim info. So where to find this file? Usually it is located under the home directory of every single user. So cd back, cd home, and we can look and find out. So basically here in this task there is a one command, one liner that loops through all the home or directories under home and gives you what vim files stored. So we have under Janice and we have under Ubuntu. Okay, so we can take a look at one of these by issuing sudo cat home and we can see the history of the commands executed in the vim session. We have a flag here, also have another flag. Probably this answers one of the questions down here. Analyze Janice vim info log. What flag do you find within the vim history? It is this one. It's the same across all lines. And lastly, we're going to take a look at a tool that's used to investigate browser history or browser artifacts. Okay, let's first clear. Now, if you want to investigate the browser artifacts, meaning extracting the cookies, bookmarks, and other information, you want to do that through the user profiles. So for example, home, and let's see ls and go to Eduardo, for example. Here we can see there is a directory named Mozilla. This directory is created by Mozilla Firefox browser. It contains the profile of the user Eduardo, and that profile contains all of the artifacts, history, meaning every browsing activity. So we're gonna cd to Mozilla and Firefox. Okay, take a look at this. So we have this profile, and this. So in order to investigate further, we want to take a look at these profiles, this one and this one. Fortunately for us, you don't need to go through these files manually. You can just use a ready script to analyze the profiles, whether it is for Chrome or Mozilla. So the link is here. It is dumpzilla. It can be used, as you can see, for Firefox, SeaMonkey, and Iceweasel. Of course, there are other tools for Chrome and other browsers. There is a ready script by the that is uploaded by the author to this room. So we can go back, ls cd investigator, and find the script here. To run the script to extract all the artifacts or the browser artifacts, we can just use sudo python 3, the name of the script, and the full path to one of these profiles. For example, here we can say home, Eduardo, and then we have Mozilla, Firefox. Okay, we can pick one of these profiles. Let's take a look at this one. Now the switches, you can choose -- summary. Okay, the summary here, we have the summary of the browsing activity. As you can see, the user here has 10 bookmarks, 34 stored cookies, 1 item in the download history, and 14 items in the history. To have more details, we can cancel this switch and enter. Now we can see the full history or the full browsing activity, including the destinations the user browsed to, the cookies. I mean, we can perform myriad of things starting from here, whether it is for forensic or for hacking. Now here there is a flag. Probably you're gonna need this flag, or we can do that. You can just use grep thm, and you can grab the flag for the last question. Okay, so that was it for this room. I hope you guys enjoyed this, and definitely I'm gonna see you later.